Alright, I'm going to now work through this problem number 9, the one with Ceres, a large asteroid in the asteroid belt. So let's see here. You're on the surface of Ceres and you are dropping a rock from 10 meters high, so that's known, and you measure the time. So the time is now known, about how long it takes for that rock to fall all the way down to the surface. So it's accelerating down and eventually hits the surface. This rock, as we know, as it falls, if I draw a free body diagram, the force on it is just the force of gravity. So we also know, so the first thing we're trying to do is we're trying to find what the gravitational field strength is, what the acceleration is. So if you remember, Fg equals mg, and what we're talking about here is we're talking about the gravitational field strength that would be in newtons per kilogram. Alright, so now let's take on this problem. We have time, we have distance. What we're trying to do is we're trying to find the acceleration, so we might use this one. Y is equal to y naught plus v naught y t plus 1/2 a t squared. Ultimately what we're trying to find is a. That a will be the g that we're looking for. So we end up hitting the ground at 0. The initial velocity we're going to assume is 0. So you end up with a negative y naught is equal to 1/2 a t squared. You end up with finding a. So that ends up being 2y naught, negative 2y naught over t squared is equal to a. And there we have it. You can find what a is. Once you know what a is, that's equal to g. We can see that it's negative, so that means it's down. That would match up with what we have here on the force of gravity. So now the second part of this is you can determine the gravitational field strength, and then the radius is such and such, calculate the mass. Alright, so if we know that the radius is given as 5.10 times 10 to the second kilometers. Trying to find mass. So let's see here. Let's now look at this. Fg is equal to big G m1 m2 over r squared. I could rewrite Fg as mg, the mass of, let's say, the rock, g, or actually mass of anything that's on the surface, is then equal to big G m1, m2, and one of these masses is the mass of that object that's on the surface. So we know what G is, we know what R is, so this mass right here is actually the mass of Ceres. So if we just solve for that, we end up with mass of Ceres is equal to big G little g, which I solved in this other part of the problem. No, that's wrong. Big G r squared over little g r squared over big G. Okay, this is a constant, this is given, this is what we found over here, and so then we can find what the mass of that asteroid is. Done.